pair of linear equations in two variables. Now, if we see what you have done in 9th class, in chapter 4, you studied chapter 4 of class 9, linear equation in two variable. You already have studied this chapter. So students, question is, what is an equation and what do we call linear equation? So first thing, an equation of the form ax plus by plus c equal to 0 is called as linear equation. Now if you notice, a is coefficient of x, b is coefficient of y, and c is a constant term. Now here the another thing that you have to note, that a, b and c belongs to real numbers. So real numbers, a set of rational and irrational numbers are known as real numbers. So a, b and c can be rational number or irrational number only. Now another important point that you must note in this case, a and b means coefficient of x and coefficient of b cannot be 0 simultaneously. So a and b cannot be 0 simultaneously. Now, what will happen if a is equal to 0 or b equal to 0 or both a and b are equal to 0? So let me take one example. Think, what is 3x plus 5 equal to 0? If I want to write it as linear equation in two variable, so I will write 3x plus 0y plus 5 equal to 0. Now here if you notice, a is equal to 3, that is coefficient of x, and b is equal to 0. So here b is 0, means 0 into y, 0. So we have 3x plus 5 equal to 0. But still it is a linear equation. No problem. It is linear equation in one variable. So if coefficient of any one of x or y is 0, still we can write it as linear equation in two variable. Now same way, if you take another example, 7y minus 2 equal to 0. Now here if we write it as linear equation in two variable form, so we will write 0x plus 7y plus minus 2 equal to 0. And here if you notice, a is equal to 0, b is equal to 7, but still we can say 7y minus 2 is an equation. Now think, if I write, what will happen if I write 0x plus 0y plus anything, say 6 equal to 0? Is it an equation? No, it is not an equation. Why? Because here if we simplify, so 0 into x 0, 0 into y 0, it means 6 equal to 0, which make no sense, right? It is not possible. So linear equation won't exist. So for the existence of linear equation, for the existence of linear expression in the equation, it is must that one of the variable must survive, right? Now here, why we call it equation? Equation, it is being called because of the equality sign. If you see only left hand side, ax plus by plus c, this is what? A polynomial. But when we write ax plus by plus c equal to 0, then it becomes equation because of equality sign, right? Now can you tell me what is the power of x and y in this equation? So power of x and y is 1. So the polynomial involved in this equation, the degree of polynomial is 1, and we know the polynomial with degree 1 are known as linear polynomial, right? And linear polynomial, if we write equal to 0, then we call it linear equation, and there are two variables involved, therefore we call it linear pair equation of two variables. So what we call linear equation in two variables. Now next thing, I hope you understand. Now if I write a1x plus b1y plus c1 equal to 0, so what it is? Linear equation in two variable. And if I write a2x plus b2y plus c2 equal to 0. Now if you see here, I am using a1, a2, b1, b2, c1, c2. It means these two equations are together, so they make a pair. These two equations make a pair. So as there are two equations, so we call it a pair of linear equations in two variables. I hope you understand. So first is linear. What do we mean by linear? Power of exponent is 1, right? A variable power is 1, so it gives us the name linear equation because it is equality sign is there in the expression, so it is called equation. And there are two variables x and y, so full name is linear equation in two variables. And in this 10th class, what you are going to do, you are not going to deal with only one equation, you are going to deal with a pair of linear equations in two variables, right? So we will further study in this chapter. Let me see what we have to do. Now another thing, once again, in 9th class you did how to find the solution of a linear equation in two variable, right? First of all, we will understand what do we mean by solution. Now solution of the equation, right? Now solution of the equation means that value of variable which satisfies the equation. Means by putting that value of variable, if your left hand side of the equation becomes equal to right hand side, then we say that value of variable is solution of the equation. For example, say 2x plus 3 equal to 0. If we simplify, 2x equal to minus 3 and x is equal to minus 3 over 2, right? So we simplified this. Now x equal to minus 3 by 2, if we take it in equation, if you see here left hand side, 2x plus 3, if you fill the value of x minus 3 by 2, see what happened. So it becomes 0, that is equal to right hand side. So it satisfies the equation. So minus 3 by 2 is said to be the solution of the equation, right? And if I put the value randomly, say I took the left hand side 2x plus 3. Now I am just putting randomly the value, hit and trial method basis. I am putting x equal to 1. So what will happen? 2 into 1 plus 3, that makes it 5, which is not equal to right hand side. So we can say 1 is not the solution of the equation, right? So solution of the equation is the value of variable by using which your left hand side of the equation will be equal to right hand side of the equation, right? So left hand side of the equation and right hand side of the equation will be equal, right? So this is what we mean by solution of the equation. Now let me discuss further. Now linear equation in one variable. What we can say about solution of linear equation in one variable? First of all, let me see what is the standard form of linear equation in one variable, that is ax plus b equal to 0. So this is what standard form of linear equation in one variable. Now here point is to be noted is a cannot be equal to 0, as I already told you. If a will be 0, x won't exist, and if variable won't exist, it is not an equation, right? It won't be linear equation. Polynomial won't be there. Now here degree 1 polynomial won't be there, so linear polynomial is not there, not an equation. So if we simplify, ax equal to minus b, x equal to minus b over a, so what we see, all the linear equation in one variable will always have unique solution, exactly one solution and unique solution, right? It means linear equation in one variable has unique solution, right? Now linear equation in two variables. Linear equation in two variables, for example, say x plus y equal to 4. Now what you can say about the solutions of the linear equation in two variables? Now we know if I put x equal to 1, y will be equal to 3. If I put x equal to 0, y will be equal to 4. If I put x equal to 2, y will be equal to 2. No, and so on. You can keep on finding. So linear equation in two variable has infinite many solutions, right? So linear equation in two variable has infinite many solutions. Now let me see two linear equations, a pair of linear equations. So x plus y equal to 4 and say x minus y equal to 2. Now x plus y equal to 4 will have infinite many solutions, and same x minus y equal to 2 will also have infinite many solutions, right? In all the solutions of first equation, and if we see all the solutions of second equation, can we say कि any value of x and y, there can be any value of x and y which will satisfy both the equations? Think about it. So what will happen if I take x equal to 3 in first equation? So y will be equal to 1. And what will happen if I take x equal to 3 in second equation and y equal to 1? So what comes? We get 2, which satisfies the equation. It means x equal to 3 and y equal to 1 exist in solution list of both the equations. x3 and y1 will exist in the solution list of x plus y equal to 4, it will also exist in the list of x minus y equal to 2. So we can say x equal to 3 and y equal to 1 is common solution for the this pair of equations. For the given pair of equations, x equal to 3 and y equal to 1 is said to be common solution. Right? Now further the question arises, okay, we found x equal to 3, y equal to 1, common solution. By hit and trial we got. Now further question arises, is it the only common solution for these two equations? Can these two equations have more than this common solution? Or can we have a pair of linear equations which will have more than one common solutions? Or is it possible to have this current topic with your last year, 9th class? To get the answer of these questions, let me link it to 9th class. In 9th class, chapter 4, linear equation in two variable, if you remember, you learned how to draw the graphs, right? So I am going to teach you from that way only how we can come to know whether a pair of linear equations can have only one common solution, more than one common solution, or no common solutions. So let me think from standard 9 point of view, because you are familiar with that. So that is the graph method. Now think, if I have to draw graph of a pair of linear equations, right? So what can be the position of the equation lines on graph? So what can be there? The first case may be the two lines that you will draw, where each line will represent one equation, will be like this. This is case 1, case 2. The lines may not intersect each other. You can say the lines are parallel. This situation is also possible, because in a plane, if you have to talk about two lines, then there are three possibilities with respect to two lines in a plane, simple plane, right? 2D. So the two lines can intersect each other, the two lines can be parallel to each other, or the third case is the two lines may coincide, right? The two lines may coincide. This can be the third case. Is there any other case possible? Can you suggest one? Think about it. Two lines may intersect at one point, two lines may be parallel, or two lines may coincide. Now in these three cases, each line represents one equation, right? Now let we study more. Let we proceed our learning with the help of graphs. So we will be taking three different pair of equations, and we will see the graph of those equations, right? So I have already done for you. Now what I have done in this case, I have taken three different pair of equations. To see, in first case, I have taken x plus y equal to 4, and second equation I have taken 2x minus y equal to 6. Now in class 9 you have learned to draw the graph, minimum two solutions you must get to draw the graph of a equation. So here I have taken three solutions, because we know by taking three solutions we can ensure our graph is correct. So for both the equations I have found three solutions, and I have plotted on this Cartesian plane. You have to use the graph paper for this, right? Now you see in this case the lines intersect, and in second case I have taken another pair of linear equations and lines are coming parallel, and the third case, in third case the lines are coincident, right? Now let me study with respect to their coefficients of the variable. In first case, if you see, coefficient of x is 1, coefficient of x in second equation is 2. So what is the ratio of a1 and a2 by comparing the given equations with standard form of linear equation into variable? So a1 over a2 is 1 over 2, b1 over b2 is 1 over minus 1, and c1 over c2 is 4 over 6, that comes to 2 over 3. So what do we conclude here? Here if you see the first two, they are not equal. So first two are not equal, we won't see the third one, immaterial, right? So when first two are not equal, see what type of graph we are getting. We are getting intersecting line graphs. No, lines are intersecting, and when lines are intersecting, they intersect at a point, and that point is a common point, and common point, whatever are the coordinates of that point, it will be said to be the common solution of the equation, right? So in this situation, whenever we can conclude, whenever a1 over a2 is not equal to b1 over b2, so we can conclude equations will have unique solution, one solution. And we can also conclude what will be the graph position. Graph of such equations will be intersecting lines. So you need not to draw the graph, you need not to find the solution. You can simply see the ratio of the coefficients and constants a1 over a2 not equal to b1 over b2. So just by seeing that, you can declare that the given pair of equations will have unique solution, or you can also say from graph position point of view that the pair of linear equation graph will be intersecting lines. And same way, if you see the second case, in second case if I compare the ratio of coefficients, so what I find, a1 over a2 is 1 over 2, b1 over b2 is 1 over 2, c1 over c2 is 3 by 4. So means a1 over a2 is equal to b1 over b2 but not equal to c1 over c2. And if we see the graph, in this case the graph is parallel lines, right? And parallel lines, we know, will never intersect each other. The lines which never intersects at any point or whose intersection point is 0 are called parallel lines. So as these lines don't share any common point, so no common point means no common solution. So we can say the pair of linear equation will not have any common solution. So we say this situation is no solution. Equations have no solution. And when you see the ratios of coefficients of the pair of equations, if the ratio of coefficients of pair of equations comes like this, a1 over a2 equal to b1 over b2 not equal to c1 over c2, so you can say equations have no solution. And for graph position you can say equations will have parallel line graph, right? And the third case, if we see the same way, the ratios, if we compare, we found that a1 over a2 is equal to b1 over b2 is equal to c1 over c2. No, all the three ratios are equal, and we see what is the graph is coincident lines. No, it means whenever you see a pair of linear equations in which the ratio of coefficients of variables and constant terms is equal, then you can say the equations will be coincident lines, graph position. And as these are coincident lines, so every point is a common point on the lines, so it means there are infinite many solutions of the pair of equations. In this case, equations will have infinite many common solutions. So we have three situations because three graphs are there, so three conditions. You can call these results as conditions, in which if we check this condition with the given pair of equations, and whichever condition the given pair satisfies, accordingly we can declare about the solution, we can declare about the graph, right? So let me summarize the thing. So condition, let me give these results as condition. So condition number 1, a1 over a2 not equal to b1 over b2. In this condition, what you can say about solution of equation? So solution, you can say exactly one solution. Equations will have one solution. You can also name it as unique solution, right? And what you can say the graph, from graph point of view, how can you state when you find the condition, this condition you find in the given pair of equation? So you can state that graph will be intersecting lines. Such pair of equations will have intersecting line graph, right? Now what we can say about equations? Whenever equation leads to some conclusion or leads to some result, solution, we call such equations to be consistent. So these equations are said to be consistent. In this case, equations will be known as consistent, right? So second case, a1 over a2 is equal to b1 over b2. When a1 over a2 is not equal to b1 over b2, in that case c1 over c2 is to be ignored. We have to ignore c1 over c2. Whatever happen with c1 or c2, whether it is equal or not equal, when first two are not equal, third we won't see, right? The third ratio we will not see when first two are not equal. So c1 or c2 may be equal, may not be equal, we will not bother about that, right? If a1 over a2 and b1 or b2 are not equal, then these results you can conclude without making graph, without finding solution. You can state these results, right, just by observing the ratios of coefficients. And third case, if a1 over a2 and b1 over b2 are equal, in that case we have to see c1 or c2, whether c1 or c2 is also equal to this or not equal to this. So there are two possibilities, not equal or equal. So I am taking not equal first. So in this situation, as we have done, lines will be parallel, no solution. The solution you can say no solution. And about graph you can say parallel lines, and as solution is not possible, so inconsistent. Equations are said to be inconsistent. Third situation, a1 over a2 is equal to b1 over b2 is equal to c1 over c2. All the three are equal. As we already have done seen the graph, whenever all the three ratios are equal, then we can say equations will have infinite many solutions, right? Because every point on the graph will be a common point, and common point means common solution. So lines will coincident, right? So graph will be coincident lines, and as solution is possible, so we cannot say inconsistent, we will say consistent but dependent. Why we call dependent? We call it dependent because the solution, when you will find, then variable solution you won't be able to find by any of the method. For finding the solution of such equations, you have to take the value of one variable from your side, and by taking that value of variable from your side, you will get the value of another variable. Means the values of variables of variables will depend upon each other. So you can say solution of variables of the equation will depend each other, that you will have to fill one to get the value of another variable. So that's why we call it consistent but dependent. So there are three type of results that we can declare, we can announce just by observing the ratios of coefficients and constant terms. So when we compare the ratio of coefficients and constant term in the given pair of equations, we can state three type of results. We can talk about solutions, we can talk about graph, we can talk about the equations, nature of equations. So equations will be consistent, inconsistent, or consistent but dependent, right? So I will suggest you go through exercise 3.2. There are the questions which are based on the ratios. For your practice, do question number 1, 2, 3, exercise 2.3.2. 1, 2, 3, 4 are all related with graph or such conditions. So you must try that, right? Thank you.